Okay, in this example, we're trying to find the arc length of a given curve, and we know that the arc length is going to be the integral. Well, here t is from 0 to 1, and then we have square root of dx dt squared plus dy dt squared plus dz dt squared dt, where this is our x, y, and z are the components of r. So we're going to have the integral 0 to 1 square root, where the x dt is just going to be 5 square root of 2. We're squaring it, plus dy dt is going to be 5e to the 5t, and we're squaring that, plus dz dt is going to be negative 5e to the minus 5t squared dt. So what we want to do is simplify this and see what we get. This is going to be the integral 0 to 1. I'm going to have square root of 25 times 2 plus 25e to the 10t plus 25e to the minus 10t dt. I factor this 25 out and have out here just 5, and then square root of 2 plus e to the 10t plus e to the minus 10t dt. Now, it might not be obvious what to do next, but I claim what's under the radical here is a perfect square. And in fact, this is going to be the integral 0 to 1, 5. This is going to be at e to the 5t plus e to the minus 5t squared dt, that you can work out. You know, if you FOIL this out, you'll get an e to the 10t and then twice the product, but the product of e to the 5t and e to the minus 5t is 1, so you just have twice the product is just 2. Then e to the minus 5t squared is e to the negative 10t, and this is a positive quantity inside here, so the square root and the square effectively cancel each other out. We have e to the 5t plus e to the minus 5t dt here, and so this is the integral 0 to 1 5e to the 5t plus 5e to the minus 5t dt. So this is going to be, we're going to have e to the 5t minus e to the minus 5t when we integrate, and this is from 0 to 1. So we get e to the 5 minus e to the negative 5 minus e to the 0 minus e to the 0. And so our final answer here is just e to the 5 minus e to the negative 5. And that's our final answer.